Welcome to the Thoughtful Software Podcast, where we discuss emerging technology, interview industry experts, and discuss how to build great software. Today, we're taking a deep dive into natural language processing. It's an exciting topic and an important piece of the software puzzle. For people, speaking and understanding is simple, but it's actually quite difficult for computers. Our conversation with Skiplist Principle Developer Josh Smith revolves around what NLP is, what it's not, and why it's so hard to do.
All right, so let's get started. Josh, it's great to have you back. The fans have spoken and they wanted more Josh Smith, so here you are. Thanks for joining us.
Cool. Did the fans really speak about that?
They did.
They did actually.
They actually loved the last episode we did. It was
all five of them, plus our parents, love you.
All right. Well, finally, I'm vindicated.
So it's good to have you on because today we're going to talk about natural language processing, or it's known as NLP.
Yeah,
and so
topic near and dear to my heart.
Yeah, and that's great to have you on. And so for most people, like speaking and understanding seems fairly simple, but it turns out for like computers, it's actually quite hard. And that's what we want to dive into today, kind of talk about what is NLP, what it isn't. And I'm very interested in why it's so hard to do. So hopefully that seems like a good conversation that we'll have. Why don't we get started, just kind of do the foundational stuff. I think that's a good place to start. And Josh, maybe you can kind of get started on telling us what is NLP and what it isn't. That'd be good to know.
So NLP is natural language processing, and it's basically all the technology around processing human languages and human speech and human writing and language, understanding language. So what it's not is it's not vision. Is probably the easiest way to say. I mean, NLP is an enormously broad area. Covers everything from speech synthesis to speech recognition to things like Siri and Amazon's Alexa, Google's Assistant, all those things. It's also covers things like question and answer. Google search uses a great deal of NLP to understand what you're really trying to look for when you type in a search. There are a lot of search related applications use NLP pretty extensively. Anything that is language related is NLP, and anything that's not related to speech or language is not.
Well, I don't want to throw buzzwords in right away, and I don't want you to cringe right away either, but where does it fall under like AI? Like, would you classify it as artificial intelligence, or, where does it fall in that field?
Well, some of it certainly falls under AI. A lot of it's more machine learning rather than intelligence related. But to understand and break down language requires a lot of things that people typically associate with AI. I generally find the whole AI umbrella to be not particularly useful, because intelligence is intelligence, whether it's made of meat or silicon.
Awesome. So jumping into the details, because this is a topic near and dear to my heart too. I did a startup using NLP, and it's just been fascinating to me. One of the things that's interesting is compilers, right? A lot of people look at a compiler and say, well, it can understand computer programming languages. Why can't it understand English? For our audience, what's the difference? And knowing that difference, why is natural language processing so much harder?
So the main difference is that computer languages fall into a category of artificial languages that were designed to be understood by another program. The compiler wasn't designed to understand programs. The language used to specify programs was designed to be understood by the compiler. And that's why it's so much harder to work with natural language, because natural language wasn't designed at all. It mostly evolved. In that evolution, like, you can specify in an artificial language things like what the syntax is, and the entire syntax can be known. And you can specify the grammar such that the grammar is completely unambiguous. Now, there are human languages that are unambiguous as well. Mostly those aren't spoken because they're kind of a pain. like English, for example, is a wildly ambiguous language. For example, this whole time we've been talking about a subject, but the subject isn't named, and the subject is understood through contextual information that speakers of English can understand, but a computer program like a compiler is never going to be able to process that because it's too ambiguous, it's too messy.
So the common terms for those, right? Context-free grammars. That's the programming language, and then contextual grammars. The English and the other Romantic languages, especially, are contextual grammars, meaning you need context to understand what people are saying. But what if we did something different? What if we took a Romantic language and bounded the context, meaning we're going to bind the grammar that you can use to a single field, we'll say medicine. Does that make NLP any easier, or is it still an unbounded problem in terms of problem space?
No, because natural languages aren't simply context-free grammars. And it's mostly because in order for something to be a context-free grammar, it has to be describable via a set of production rules. And natural language can't be described via a set of production rules. Now, you can restrict things to specific jargon, and you can sort of pretend that they might be able to be describable via production rules, but that's not necessarily true.
Bounded context doesn't work. And so, what if we're going to go about that? We're going to try to interpret one of these grammars, we'll say English. What are the predominant ways computers might be able to learn that grammar and be able to interpret it in at least an efficient way? Maybe not an entire way, but something like Google. How can they go about training something to interpret what people want to search for?
Well, so for something like Google, it can be really easy. I mean, one of the processes that's used to take a search query and filter out things that aren't necessarily useful is you can restrict the vocabulary. So there's an idea in a lot of NLP toolkits for stop words, like the and things like that. And so you remove those. So if I type into a Google search, this isn't really how Google does it, but if I were going to build a cheap Google, and somebody types in what is the capital of New York, I might remove the from that sentence, and I might remove what from that sentence, leaving me with just is capital New York. And so now I have a verb, an adverb, and a noun. And so I can map that to a set of rules that if I get that kind of thing coming through, that is an intent to find out something, to find an answer to a question. And then I can use question and answer techniques. Like, for example, the Stanford question and answer data set, it's called Squad. A lot of tools are written to process that data set to answer questions. That uses Wikipedia and things like that, and other various knowledge graphs. And so if I say, what is the capital of New York, removes the stop words, it takes what's left, pushes that through a Squad database, and comes out with what's the capital of New York. So it might, now the question is that it might be Times Square. It might also be, actually, I forget what the capital of New York State is, but it might answer the question of the capital is Albany. It might answer what is the capital of New York State, because it knows that a city, if it parses it further and pulls out the entities that are there, so New York would be an entity, and New York could be an entity of a state, it could be an entity of a city, and it's most likely a state. And so the answer is Albany is what is the capital of New York. Does that answer your question, Andrew?
Yeah, that's really good. When we talk about data sets, right? The interesting thing about data sets is how you clean it up. And number data sets, I mean, it's kind of clear. We've been cleaning up number data sets for, I don't know, millennia almost, it feels like. So it's, we look at that and we say, holy crap, you just remove the outliers, you normalize, and you can kind of fill numbers. But when it comes to words, stop words is one thing, but are there other words that we'll say are irrelevant to understanding a sentence? Maybe adjectives. Does that, does removing adjectives help as well?
It might. It depends on the problem. That's where, at the beginning, one of the things I said is that NLP is a huge topic. Removing stop words and using the frequency of terms that show up in things, that's one way to handle it. Sometimes that's not the best way to handle it. And that's one of the things. Lately, there's been a huge amount of research published about NLP models and things like that. Like Albert is a Google model that was published in October of this year. And Albert is based on BERT, which are, all these are acronyms, but Albert was able to take the SQUAD, the Stanford question and answer database, and beat the human best for question and answers within that data set. Albert doesn't do simple stop word removal and term identification. Albert's a crazy complicated, I haven't read the paper yet, but BERT models are enormous, and Albert's based on BERT. As things get better in NLP, especially in generic sort of language recognition, the stop word removal and stuff like that and grammar constraints tend to not be the best solution, and they use these neural models, with much like machine vision models in the recent past. They're big models.
Interesting. So when the field first started, people actually were using decision trees to kind of parse, and they'd be gigantic decision trees across a lot of different word combinations and different kind of decisions they could make. And obviously that proved to be not feasible.
Well,
and so
I don't know if it's, not to interrupt you, but I don't know if it's not feasible. A lot of enterprise NLP still uses decision trees.
Well, okay, I'll actually, you're absolutely right. I shouldn't use the word non-feasible. It's not feasible on the general problem of I'm going to interpret English, right? There's just too many branches for the decision tree, and you could, in theory, with a big enough supercomputer, have multiple trees and different breakpoints and store the tree. And there's a lot of algorithms around trees that could make it meaningful. But Google seems to have moved towards a statistical model, and that seems to be the direction they're going, because it seems to be easier to statistically calculate a likelihood of a word meaning something, rather than using pure decision logic for it. But do you think there's like a approach we're not looking at that isn't statistics? I mean, statistics seem to have carried us really far when it comes to computer intelligence in almost every field, just because of the general applicability of it. But what else do you see in the field that might be a alternative to deep learning neural networks and things that are just eating every branch of computer intelligence?
I don't know. Deep learning neural networks are pretty much winning the game. I mean, a lot of it depends on what you're trying to do. I mean, the Jeopardy was, beaten up by Watson in 2011. And that was a pre-deep learning system. That was mostly decision trees and a lot of custom NLP stuff around inverting question and answer databases. And a lot of it was text to speech and speech to text too. For the natural language understanding part, it sure looks like neural methods are eventually going to completely take over. There are a lot of places where you can do rule-based systems that are much faster, like take a lot less memory and a lot better computer time. Entity extraction is one thing. Like if you're just taking, let's say you have a bunch of documents and you just want to extract all the entities out of it, rule-based entity extraction is pretty darn good and will do everything that you need to do currently without resorting to neural methods. But for the general problem, it does look like neural methods are going to win. But that being said, most people aren't trying to solve the general problem. Most people are trying to do a specific thing, because document categorization is an NLP problem. And we've been doing that for quite a while. And while there are some neural methods that are starting to show up in the document classification area, a lot of that's still done with decision trees and statistical methods. They're fast, they're easy to understand, they're easy to reason about. One of the big problems that the neural methods have is it's often very difficult to answer the question, why did document A get classified the way it did? If you have a neural system, but if you have a statistical system, you can tell why that happened. You can answer that question.
It's all right, Josh. We'll look at our system of 10,000 functions with 26 variables apiece, and we'll reason about that to find out why document A is this type. It'll totally make sense, and we have time for it.
Yeah.
I was curious within the decision tree, how do computers like decipher intent? You know, because one question could maybe mean two or three different things depending on how you say it.
A lot of that, the answer to that is more statistics. For example, if I say, pass the bottle, is that a bottle of water or a bottle of beer? If I know how many times that you've asked that question to me before, and I know how many times it was beer or water, I can make a reasonable estimate as to what the likely intention is on that.
And Fahad, to continue the answer and give a timely example. So recently there's this fraud issue, or not fraud, it's a credit scoring issue with the Apple Card and the gender discrimination that's happening. And because these decision trees, which is often used as a pattern for making credit decisions, see different outcomes and likelihoods, and if you don't clean and do good data prep and remove biases and things that are just good to do, that statistical outcome gets skewed. And you have what Goldman Sachs and Apple have on their hand, which is a potential gender discrimination suit and a bad couple weeks of press. So even with the statistical outcome thing, it's very important that you look at the outcomes and then also the input of where the input's coming from when you're looking and trying to choose your next decision inside a decision tree.
Yeah. And in neural models too. Misogyny in, misogyny out. If your data is biased, your outcome is going to be biased, whether you're using statistical or neural methods.
Yeah, so that's such an interesting point actually. So you have a question and you have a decision tree to understand, okay, this is a question and you know generally what the intent is. Where are you finding, I mean, this may be a dumb question, but where are you finding this data? Because if it's just the internet, how do you actually clean that up so that, you get the data that you want? How are they supposed to take out the bias when they may be trying to look at multiple sources that are not their own? It's just public data.
I'll take this and Josh. So science has been doing this, I don't know, for like 200 years or whatever, looking at other people's data and saying, is that correct? Is this the truth set that I want to use? So there's a lot to learn from just statistical relevance and all of that. I also believe it's in the realm of the responsibility of the person using the data to go through it and wait and basically give a weight. If you look at like PageRank when it first came out, why is PageRank so popular and powerful? Why did it kind of fix the internet for a little while? And the reason it did was it gave weight to different sources. So if I was linked by Fahad's site, that has one weight, but if CNN links me, that has a completely different weight because they're considered a credible source, right? And so, where you're getting your data from on the internet matters. And so you want to get it from credible sources. You want to know and understand the researchers that may have collected that data. And that can come down to who was on the team that collected it. Was it a diverse team or was it a non-diverse team? And then look at the data. I mean, it's up to the people using the data to understand their data, right? If you're going to use materials, right, and you're like, I'm going to build a house, you're not going to say, hey, Lowe's, give me whatever wood you have, and I'll build it with particle board if I have to. That's not how anyone does stuff, and programmers can't be the exception to the rule. And the third thing is when you're looking at data, like I said, weighting data sources differently, looking at your data, understanding your data, and third, understanding the source. Those are a couple ways, but there's also, like I said, examples from science, physics, chemistry of how people remove data. Psychology and sociology actually are really good at this. and they remove data really well. I mean, a lot of scientists don't think that those are sciences, but we can definitely apply approaches. Usually there's statistical approaches, making sure you have a good sample size, things like that. If you do all that, you will have a lot less bias. And also having a diverse team of people looking at the data, because we all have different viewpoints. And so I might see data one way and Josh might see data a different way. And I might say that's not biased data, and Josh says, "Holy crap, no, there's a lot of bias in that data. What are you looking at?" And that's why it's important to have peer reviews and studies and models, especially now where we're getting data from a lot of different sources and kind of gluing it together.
And I would argue that the social sciences have not historically been all that good at removing data. I mean, one of the things that's coming out of a lot of this algorithmic stuff, like the DHH's tweet, is that normal people are finding out that there's structural misogyny and racism within our society, and no amount of data cleansing is going to remove that. So if we know they're biased, what we have to do, instead of just relying on data cleansing, is working toward understanding how we can mitigate the harm of decisions that are made by algorithms within these systems, and making sure that that can be fixed once it's identified. But NLP is a good example. You can there's a thing, it's called it's like word golf or language algebra, that you can do with word vectors, and you can do things like put in a word and then it'll find a similar word. So you put in like criminal and it'll come out sheriff, or things like that. You can take a given body of textual information and play word golf with it and find all sorts of sexist and racist things in it. Pretty much, especially if you're using Wikipedia, you're guaranteed to find it. And sometimes it can be really embarrassing. So you have to be careful when you do that. A lot of the NLP researchers are well aware of that, and they try to limit it, but sometimes it's difficult to detect except at statistical scale.
Well, so that's another interesting thing that I always think about is, so like, let's say I search that, hey, Siri, show me, the latest news. And I'm always like curious on what type of news it wants to show me. And is there any bias towards my own personal preferences or where it's grabbing the data? And, you get the information, but, I think Google's been criticized for this, where it just kind of shows you what you're thinking about, based on your preferences, rather than showing you maybe something that's just factual. It could be a lot of opinionated articles. So again, that's where my question comes from is, how do you, decipher where is the right data and what to show the user?
This is a really interesting point, Fahad. I personally call it the algorithmic decline of intelligence. But what really happens, like Facebook's especially guilty of this. So let's say I read an article from Fox News, because why would I do that? But let's say I do. From Facebook, I click on it because my crazy aunt links it. I read it. I come back the next day. They're going to show me more things tilted towards that viewpoint. And the more I read from that, because that's where I'm getting my news from, the more I slide down this trail into my own little subgroup of people that now we all have the same opinions because we've all read the same news and assume the same facts. And I've now tribalized myself in a way where I'm now surrounded in my echo chamber of everyone that agrees with me, and Facebook is feeding that by just continually linking me things. So I click on their stuff that gives me confirmation bias of the facts that I believe are true. And Google and Apple do the same thing. Oh, you read about fitness, we're going to keep showing you fitness stuff, right? You read about this, I'm going to keep showing you this. And they know you're, quote, interested in it. And so they want to keep having you come back and click their stuff and interact with their service. And so they'll continue to show you stuff you're interested in, and it creates echo chambers. Facebook has hilariously tried to fix that with their new news tab thing where they try to show diverse opinions, but then they put really extremist stuff in there. Like they accepted Breitbart as a legitimate news source, and they've accepted a few other ones that are just blatantly and hilariously bad. And they're trying to fix the problem. But I think what they're going to find is there's a perverse incentive for them. If people stop clicking articles, I stop making money on advertising because I don't know what people like. But I want to show people diverse and non-echo chamber content. But people are less likely to click on things they're not interested in. So it'll be interesting to see how they go. I'm curious. What do you think about that, Josh?
Well, I mean, on one hand, so Noble's book, Algorithms of Oppression, covers a lot of that really well. So does the Weapons of Math Destruction by O'Neill. To a degree, though, the filter bubbles, I think, are less dangerous in that sense than some of the other stuff that comes out of, particularly with AI models, as far as like creditworthiness, mortgage rates, availability of parole. A lot of that stuff is handled by black box ML algorithms now, and that's a big problem. But I highly recommend both algorithms of oppression and weapons of math destruction. They're both quite readable.
So that begs the question: if an enterprise is interested in, adopting more like NLP type applications, and they're seeing some of the criticism some of these larger companies are facing, like let's take an example like McDonald's. They want to, I think they've already rolled out chatbots and applications where you can just order, which seems fairly simple. Um, are there degrees to how difficult something like that might be, just creating like an ordering application as opposed to something around document management, or like maybe I guess I could back up and say what's a good place for enterprises to get started without like facing a lot of criticism for some of the things that they might want to do.
Well, one place they can do is they can turn NLP on their own documents. So one of the things that you'll often hear in larger organizations is that they can't find the information they're looking for. Like if I want to know about a part, like let's say I'm working for Ford, okay, and the Department of Transportation has released a report about something that's impactful to what I'm doing. How can I find that? And how can I relate other documents within my area at Ford with the Department of Transportation's documents? That's an area where NLP can be applied without a lot of concern about bias or any of these issues that we've talked about here. So the biggest thing I would say is just that pick your targets carefully if you're going to apply NLP within your organization.
So I had a question on that. When you say apply NLP, what do you mean by that? I mean, I see like this is just a search engine, right? But when you applying NLP, what do you mean by that?
So let's say for NLP, so search is one place that natural language tools are very useful because I can categorize documents based into different categories based on their content using NLP tools. I can extract entities from them. Like I could set up a system of rules that specifies entities. Like if we're going to use the Ford example, say, car names are then entities. So if there's an internal report about a Mustang, then I know that report is a report about Mustang cars, not horses. And so when I do my search, I can search for only documents that relate to the Mustang car. I can also use NLP to summarize different data. For example, I can use NLP tools to, if it's a memo, maybe I can summarize it down to a paragraph. And then I don't have to read the whole document. I can just read the summary. Those are two examples.
So that space is commonly called e-discovery, right? That's the market thing. I don't know if I like that term, but we'll call it that because that's the
e-discovery is often applied particularly for legal.
True. True. So you would say scan your documents and search on them. I think that's really good.
Yeah, and enhance your search, because one of the things a lot of companies right now are doing is they're using term frequency, TF-IDF, term frequency and inverse document frequency to find things. That's a really crude way of searching. By enhancing documents with both like entities, other kinds of more sophisticated content analysis in the document, allow people to search for things in a much more targeted fashion rather than just looking for tokens.
So you're talking about like building a knowledge graph for a company using terms and other entities to know, hey, these are all the documents that are pertain to this car, but inside these documents, these also pertain to maybe the Department of Transportation on approval, maybe a department, EPA, things like that. And are
Yep.
yeah, that would be, most companies don't have that to be powerful for people.
No, most companies don't, because right now a lot of times they're basically using a souped up version of Lucene for text search.
Mm.
And that also allows you to then, once you build that knowledge graph, then you can reason about the graph in ways that you can't do before. I mean, that's one of the things that makes Google so powerful, is that Google's able to not only reason about the things that you're searching for, but its relationship to other things, and to say, hey, this concept is related to the concept that you just searched for, and then you can feed back in what the person clicks on when they do a search, and to say that that estimate is correct and maybe needs to be bumped a little bit, or that estimate is incorrect and needs to be dropped down a little bit. But that evolving sort of understanding of the relationship between pieces of information within your organization is a very powerful thing.
So are companies investing money in this specific application, or are they not even thinking about this yet? Or is it not feasible?
Oh, it's totally feasible. Some are, some aren't. A lot of it depends on how forward thinking they are. I mean, there are a lot of organizations that are doing some of this stuff, but many of the larger organizations, are they going to do it enterprise wide? Perhaps not. It oftentimes goes department by department. Legal teams tend to be, like corporate legal offices are an absolute like arm to the teeth with NLP technology. Westlaw and LexisNexis are both organizations that have made extensive use of NLP within their tool set, and they provided corporate legal departments with just an absolute, uh, like I said, just arm to the teeth with NLP technology, and for for understanding contracts, for all kinds of stuff. It's really amazing. Purchasing departments, probably not so much. I don't know that many purchasing departments outside of the Department of Defense that use these technologies. There are several contractors right now that are providing some of the stuff to the Department of Defense, particularly NLP related to contracts, and they've had some successes. It's a little, it's a little tougher to do in that market, but yeah, I guess the answer to your question is some are, some aren't.
Well, if a company does, like, let's say a bank, roll out this feature, they want to implement this, is it difficult to maintain this level of, like, NLP application within the system, or is this something they can do with like a kind of a small team, or like how much investment is really needed to kind of maintain something like this?
It doesn't have to be a huge team. I mean, a lot of it depends on what the value is. It can be done with a relatively small team, but it does require specific expertise in applying this kind of stuff. And it's also, a lot of times the biggest barrier isn't technology or skills, it's document management systems and siloing within these organizations. In order to effectively apply NLP, you need data, and if you're going to limit it to inside the organization, you need the ability to access that data in a format that's readable. If it's like, let's say your department has 5 years worth of memos about sales, right? But they're all in PDFs. That can be a sticky wicket. you want the text. You need to be able to extract the text in order to analyze and operate on the text. If they're in scanned faxes or PDFs, that's a lot more difficult. But it does take, it mostly takes an institutional investment into the technology, and a lot of times it takes staff. Some people have, there are a few products out on the market that companies are using for SaaS. IBM, Google, and Amazon all have cloud-based NLP tools that they've been aggressively marketing within organizations. HP Autonomy has a bunch of legacy search appliances basically that they sell in that space, but there's no winner yet.
Would it ever make sense for a company to not use like a cloud service like Google or Amazon? Should they roll out their own? Is that even something that they should entertain?
I think it depends on what you're doing. Like, for example, Standard and Poor's, the company behind like the S&P 500 and a lot of financial data, they maintain a relatively large NLP team. That's their bread and butter. So should they hire that out? Probably not. The big question that I always ask people is this a core part of what you do to make money? And if it is, then you should do it internally and you should not outsource it. If it is not a core part of what you do to make money, then you should absolutely not do it internally and you should outsource it. And by outsource, I mean use a cloud product or a third party. But it comes down to the end of the day, the standard build versus buy kind of thing.
I think this is a really interesting conversation. We kind of wrap up with when, like, so you have enterprise space and then you have like the consumer, which is, which gets all the news media like chatbots and things like that. When will NLP be like a seamless experience in the enterprise? And then when do you think it'll be a seamless experience for like just consumers?
I think in some areas it's pretty close. I've had an Amazon Echo for 5 years. I was one of the first, like I got my first Echo when it was still in limited beta. Amazon's home products are pretty close if you stay in the lane of standard stuff, like turn on the lights, turn off the lights, what's the capital of Patagonia, how many what's the question I asked the other day? How many miles are in 2,000 kilometers? Stuff like that it handles that super well. So does Siri and Google's assistants as well. I think product wise, the next 5 years is going to see a sea change in consumer electronics and voice interface systems. And I think it's primarily going to be led by Google and Amazon and Apple. Apple's pretty far behind on a lot of the stuff. So
Why are they so behind?
Well, that's more of a strategic question. Siri was an acquisition by Apple. They didn't build it internally. Their customers, it probably comes down to Siri doesn't help them sell iPhones right now. But I think with the AirPod Pros, the AirPod Pros are a device that really has no other role besides making voice communication for interfaces better. AirPod Pros are a really hopeful sign that Siri is about to get way better. So that should be interesting. But no, I don't know. I don't know why Tim Cook won't return my calls.
Oh, it's crazy. He won't return mine either. Fahad?
Yeah, and his lawyers keep telling me to stop calling.
I have him on speed dial, so let me check. But he has 200 billion in the bank, so I'm sure he could figure it out.
But yeah, a lot of it is voice interfaces have some very huge barriers between their wide adoption. If you've ever seen the movie Her,
yeah,
that tells you about one possible terrible future world of voice interfaces. Because everybody's always talking in that movie. Everybody's always talking. And NLP interfaces can't rely on our world being filled with people muttering to themselves.
Interesting. Thanks for listening. You can always connect with us at skiplist.com.